T10.9. A quiz question gives random samples of n equals 10 observations for each of two normally distributed populations. Tom uses a table of t distribution critical values in 9 degrees of freedom to calculate a 95% confidence interval for the difference in the two population means. Janelle uses her calculator's two-sample t-interval with 16.87 degrees of freedom to compute the 95% confidence interval. Assume that both students calculate the intervals correctly. Which of the following is true? All right, so the main difference is Tom is using 9 degrees of freedom, Janelle is using 16.87 degrees of freedom. All right, let's take a quick look at table B and see what how those critical values would differ. All right, table B. All right, I wonder if it said what the confidence level, 95%. Okay, so for 95%, let's erase this. Right, Tom was using 9 degrees of freedom and Janelle was using 16 point something, so we'll just say 16. Okay, so the main difference is that Tom's critical value will be bigger, Janelle's critical value will be smaller. Okay, and because the critical value is used to get the margin of error, that means Tom is going to have a wider margin of error, right? So his confidence interval will be wider, and Janelle's confidence interval will be a bit narrower. I'm exaggerating here a little bit because the difference isn't that much, right? It's in the tens place where it differs, okay? But generally speaking, Tom's going to have a wider interval. All right, choice A, Tom's confidence interval is wider. That is a true statement. Okay, he'll have a bigger critical value and therefore a bigger margin of error. All right, B is false. C is false. D, there is insufficient information. Nope, all we got to do is look at table B. So that's false. Janelle made a mistake. Degrees of freedom has to be a whole number. That is also false. So I might have mentioned it briefly in class. So we use the conservative approach when we do this by hand, right? We say, look at the two samples, find the degrees of freedom for each one, and then just use the smaller degrees of freedom. That's always going to lead to a bigger critical value and a wider margin of error. It's called the conservative approach. The calculator actually uses a very sophisticated method to get the degrees of freedom, which is why it ends up being a decimal, not even a whole number. Okay, but that method is actually a bit more accurate. Okay, either way, College Board is going to accept either the conservative approach, which is what Tom did, or the more accurate approach, which is what Janelle did.